This video introduces a script that you can use to create your own Tigris workflow components. Specifically, we will create the dsplot component shown in this workflow. A number of components already exist for use by the LearnSphere community, and we invite users to contribute their own. Components generally fall into one of 5 groups: import, analysis, transform, visualization, or tetrad. With this example, we will create a visualization component written in R. The Tigris workflow components are publicly available on GitHub in our LearnSphere workflow components repository. The workflow component creator script, run wcc.sh, is available in this repository, as well as the template files necessary to create a component. We suggest cloning our GitHub repo to get started. You will need the Java 7 development kit to run the component creator. Other requirements for building and testing the workflow components are listed in the repo README. While the component creator will generate the files necessary for a new component, more details on the files and advanced functionality can be found in the Components Overview section of the Workflow Components document in our GitHub repository. You will specify the metadata of your component, including component inputs, outputs, and options in a properties file for use by the script. There are example property files in the templates directory of the GitHub repository. In this example, we are creating a component named dsplot. It is a visualization component and is written in R. For non-Java components, you will need to specify the directory where your code can be found. It will be copied into a new directory created for your component. You will also indicate which file to run. For example, in a Python or R component, you will indicate the .py or .r script that the interpreter should execute. In this example, the component program dir contains 6 R scripts, but the main script component program file is dsplot.r. Next, you can specify your name and email address. These are used to populate the info.xml file that includes the metadata for a component and will appear in the component description panel for all users to see. You can later edit the file to include more detailed descriptions of the inputs, outputs, and options of your component. The remainder of the properties file is used to specify the inputs, outputs, and options for your component. Begin by specifying the number of each, for example, component.num inputs. In this example, the dsplot component has 1 input, 1 output, and 6 options. For the inputs and outputs, you will specify a file type. The naming convention is input.n.type, where n is the input number incrementing from 0. This component takes a Datashop student step as input and generates an image file. So input.0.type equals student step, and output.0.type equals image. For outputs, you must also specify the name of the output file. This is necessary because one of the generated files will reference this output file. In this example, the R script creates an image file named curve.png, specified as output.0.name in the properties file. For each option, you must specify the type, name, ID, and default value. The options use the same naming conventions as inputs and outputs, option.n.type, option.n.name, etc., with n incrementing from 0. The options will be passed to your program, dsplot.r in this example, as command line arguments. So an option with the name lineType is available to your program as -lineType space value. The most common option types are string, double, enum, and file input header. The file input header type takes a regular expression and tries to match the column headers in the input file. For example, the first option will match those headers of the form kc space any string with parentheses around it. If the default value of an option looks like a regular expression, we will try to treat it as such. For instance, to allow the user of your component to select from any input column, use a default value of .*, which matches any word with 0 or more arbitrary characters. The enum option type has the syntax enum, open paren, a comma separated list of values, close paren. In this example, the line type option is an enumerated list with values discrete and smooth. In the UI, users will have a drop-down select box to pick from these 2 options. With the input, output, and 6 options specified, we are ready to run the script. The script takes 2 arguments: the path to where the templates directory can be found, and the properties file that defines your component. If you run the script from within the directory where it resides, the directory you cloned from our GitHub repository, the syntax is as follows. This is assuming that you've created your properties file in the same directory and named it wcc.dsplot.properties. The dot preceding the properties file name indicates that the templates directory is in the same directory as well. Running the script creates your component with all the necessary files in a directory named for your component. In this case, the component can be found in the new dsplot directory. The workflow component creator has created the files necessary for the new component. In some cases, Java components especially, the new files are merely templates and you will edit them to provide your own component functionality. We will walk through the generated files now. Info.xml. This file contains the metadata for your component, formatted for use by Tigris in the UI for tooltip and option dialogues. Build.xml. This is the ant build script for your component that also includes a test target. Build.properties is the properties file that specifies paths for the interpreter and program for your component. In this example, the interpreter is R script and the program is dsplot.r located in the program subdirectory. This is empty if your component's language is Java. Program is the subdirectory containing the script or scripts necessary to run your component. Schemas is the subdirectory containing the XSD which specifies inputs, outputs, and options for your component. Source is the subdirectory containing the Java wrapper for your component. If you are creating a Java component, you will edit the generated wrapper to include your functionality. Test is the subdirectory containing an XML file that can be useful in testing your component. More details about the generated files can be found in the workflow components document in the GitHub repository. In this workflow, we are using the newly created dsplot component. The input and output file types are labeled according to the information specified in the properties file. Likewise, the component options dialog has been created to reflect the options specified in the properties file. For example, the 5 options for legend position are listed in a drop-down box. The LearnSphere workflow components GitHub repository has examples of each type of component for each different language option. The analysis AFM is a Java component, analysis BKT is written in C++, the output comparator is written in R, tetrad search calls a Java jar file, and analysis PyAFM is a Python implementation of AFM. Nearly all of the components serve as excellent examples for how to structure a component, test it, and make use of the various Tigris functions. We are working to create a second video to discuss debugging options and next steps, getting your component installed in Tigris, etc. But if you have any questions, you can reach us at this email address.